In this video, I'm going to talk about aqueous or solid or precipitate. Okay, so this worksheet will be working together with the solubility rules, and this paper will be given to you, and you don't have to memorize anything on the top, but you have to understand anything on the bottom. But that will be next part. Okay, we'll just concentrate on the top part, solubility rules, and this is only for double displacement. Okay, now first of all, how do you read the solubility rule? We have two kind of compounds. We have reactants, we have product. So the top part of the solubility rule is any compound containing these ions are soluble in water. So what does it mean by soluble in water? Meaning they're aqueous. Now, soluble in water is like when you have a compound, AB, okay, with the plus and minus, like ionic compound. A is the plus, B is the minus. When they dissolve in water, they will be decomposed into A plus and B minus. A plus and B minus. So they will be separated. Okay, so we so-called aqueous. So what kind of compounds they will be solved in water? We have acetate, alkaline metal, ammonium, bromides, chlorides, nitrates, sulfate, hydride, and iodides. So those are any compound with this thing will be solved in water. So if they say soluble in water, we will say that they're aqueous, AQ, because they will be separated into ions, plus or minus. Now, as long as they are soluble, we will have two different kinds of compound. We can have soluble reactant. We can also have soluble product. Soluble reactant or soluble product, we all call them aqueous, AQ, the state. We also have some exceptions. So if you see the word except, okay, meaning except soluble, meaning that will be opposite to soluble. In other words, will be insoluble. For example, if I have iron 3 acetate, so you are not just looking at the iron, you have to be careful of the charge. This iron 3 plus is not iron 2 plus. Okay, so if iron acetate in water, then you will read the sentence. You will say acetates are soluble except those of iron 3 plus. So that means I will have except soluble, so will be opposite, then will become insoluble. In other words, iron 3 acetate will be insoluble water because iron 3 will be in the exception. Okay, and hydride and iodide, they have the same exception list as bromide and chloride. Okay, so if anything with the exception will be opposite to the word soluble. Okay, another part is insoluble. So anything compound in this list will be insoluble. Carbonate, chromate, hydroxide, oxide, phosphate, sulfide, fluoride, and sulfite. And be careful, you're not just looking at the name, but you're also looking at the formula with the charge. Now this, they are insoluble in water. If they're insoluble in water, meaning that when they go to water, they stay as compound. For example, AB or CD, okay? If CD is put in water, they will stay as CD. They will not separate into C plus and D minus. They stay together. So they are so-called not aqueous. Now, because we have reactant and product, we can have two different kinds. If they are insoluble reactant at the beginning, okay, at the beginning, insoluble reactant, just like I'll give you a bottle of the chemical in the bottle, insoluble reactant, we will call them solid. If they're insoluble, but they are product at the end of the chemical reaction, they form precipitate, then we will say insoluble product will be precipitate. And also they will have exception. Okay, if for example carbonate, if I give you ammonium carbonate, so how do you read it? You will say carbonate are insoluble except NH4. Okay, so except in not insoluble, then you will create the opposite word, which is soluble. So carbonate are soluble except those of ammonium. So ammonium carbonate will be soluble in water because ammonium are in the exception list. So anything you see except will be opposite to this word. Anytime you say except will be opposite this word. If you have no exception list or the compound that I give you the name are not in the exception list, then you don't have the exception statement. You will just have the front part. Okay, so maybe I'll give you the example. You will be more clear. So if you have a color paper, then you have to print out the color paper will be better. If you don't have color paper, then you want to color them. The first sentence will be red, second will be blue, and third one will be green. So anything aqueous, we will say AQ. And aqueous, I can have soluble reactant or soluble product. They meaning aqueous. If it's a solid, we will say soluble. I'm sorry, if it's solid, we will say solid S, okay? So that means that they are insoluble reactant. Insoluble reactant that we will call solid, and meaning that they are not aqueous. And if I have precipitate PPT, meaning that they are insoluble, but they are product, they will call PPT, and they are not aqueous. So aqueous will meaning either soluble reactant or soluble product. As long as they are soluble, it doesn't matter they're reactant or product. But if it's an insoluble, then you have to look up, are you product or you reactant? If you are insoluble reactant, will be solid. If you're insoluble product, will be PT. And they both not aqueous, meaning that they cannot be separated into charges. Okay, so let's look at the let's turn around and look at the question the other way. If it's soluble, we say that aqueous. Okay, soluble is aqueous. So if I give you soluble reactant, if I say reactant, so soluble reactant, then we will say it's aqueous. So AQ reactant. If it's soluble, also aqueous. Or if I give you product, that we'll call soluble product will be also AQ. Anything soluble, we will say aqueous. And the insoluble meaning not aqueous, okay? The insoluble meaning not aqueous. So if I give you reactant, it will say insoluble reactant. That would be like a compound that I give you in the bottle at the beginning before I do anything. I give you a bottle of chemical at the beginning. I did not do anything. So then it will be called solid. S. And if it's something insoluble, but that is a product, so that would be at the end of the reaction. Okay, they form precipitate. So insoluble product, we will say precipitate. Okay, so this color, I follow the same color as here. So red, blue, and green. And black pen. And if you have soluble except, again, when I see except, meaning opposite to this word. So opposite to soluble will be insoluble. Okay, and then insoluble except, so except meaning opposite to insoluble, then we will say soluble. Okay, now I'm going to ask you to circle ZnBr2, NaF, PbH2, and also mercury to iodide. Those are the 4 questions that I will go over. And let's look at the example. Again, if you have no color, I want you to circle the color. Okay, so then you can see which one is which. So let's look at the example. NH4 3. So if you do crossover, you will find out that is NH4 plus and then N3 minus. So we always look up. We don't have N in the list. Okay, in the main list, but we have NH4 plus. So let's read it. NH4 plus, and then exception could be nitrite. Exception could be nitrite, and we look up NH4. Okay, so NH4 is ammonia. So NH4, how you're going to read it is NH4 plus are soluble. NH4 plus are soluble. And there's no exception sentence here. So we will just write NH4 plus are soluble. NH4 plus are soluble. That's it. Okay, and then I give you its reactant. So you will write soluble reactant. And soluble reactant will be aqueous. Soluble reactant will be aqueous. Okay. And the next one is CaSO4. So if you cross over, you will have CH2 plus, SO4 2 minus. So we're looking for SO4 2 minus, and we see if calcium is exception. So SO4 2 minus is sulfate. So how are you going to read it? SO4 2 minus are soluble. And we have CH was. Let's see if CH was in the list. Oh, yes, it is. Okay, so SO4 2 minus are soluble except those of CH2 plus. Then you should stop. Why I don't include those SL2 plus, VH2 plus? Because they are not in the question. I don't need to list out anything that they're not in the question. I only list out the one that I have it. So SO4 2 minus are soluble except those of CH2 plus. Okay, so SO4 2 minus are soluble except those of CH2 plus. Now black pen, you see exception. Okay, so we underline soluble, we underline except. So this That means that I have to use the opposite word. The opposite word is insoluble. So blue, black pen here. Okay, when I have insoluble reactant will be solid. So that's why I use blue pen, insoluble reactant, solid. Let's say FeO. So you have to do crossover because sometimes, like especially multiple charge, ions multiple charge. So Fe2 plus and Fe3 plus, they are not the same thing. Okay, they may not show up, both of them. So this is Fe2 plus O2 minus. This is Fe2 plus O2 minus. So you don't want to say this is Fe3 plus because it's different story. Okay, so this Fe2 plus O2 minus. So we're looking for oxide and we're looking for Fe2 plus. Okay, so oxide, how do you read it? Oxides, O2 minus are insoluble. But do I have Fe2 plus here? We don't. So we don't write this part. We just write O2 minus are insoluble. That's it. So O2 minus insoluble. And insoluble product will be PPT, green pen. Okay. And then the Na2CO3. So if you cross over, you get Na plus and then CO3 minus, and then Na is group 1. So we find out carbonate. Okay, so we find CO3 minus. So how do you find CO3 2 minus? How do you read the sentence? CO3 2 minus are insoluble. Do we have exception? Yes, we do, except those of group 1, because Na is group 1, except those of group 1. So we gotta write CO3 2 minus are insoluble except those subgroup 1 because Na is group 1. Now we do have exception here. Okay, so we underline insoluble except. Insoluble except meaning soluble. Okay, so we have product. So soluble product will be aqueous. Anything soluble will be aqueous. Okay, so we now start to do the first 3 questions. Okay, so ZnBr2, we cross over, we get Cn2 plus Br minus. So we're looking for Br, and then we see if zinc is a exception. Okay, so bromides. So how am I going to read it? Bromides, Br minus are soluble. And do I have zinc 2 plus here? No, I don't. So I would just write Br minus are soluble. That's it. So black pen. So Br minus are soluble. Okay, then that's it. You don't have any exception for zinc. Then you just write this. Okay, and so this is soluble product. So we use red pen. Okay, so this is soluble product. So soluble product will be AQ. Anything soluble will be AQ. Okay. Next one, NaF. So we cross over, we find Na plus, F minus, and Na plus is a group 1. So we want to look for F, fluoride, and to see if Na is the exception. Okay, so F minus, how do you read it? F minus are insoluble. Do I have exception? We do, because except those of group 1, Na is a group 1. Do we need to include ammonium? No, because ammonium is not in the question. So we will say F minus are insoluble except those of group 1. Again, because Na is a group 1. So black pen. Okay, so you may want to make sure the sentences are on the top. Like you may have exception. You may need to leave the space for the bottom. So we're gonna write F minus are insoluble except those of group 1. Okay, F minus are insoluble except those of group 1. Now we do have exception, insoluble except, we underline it, insoluble except meaning soluble. Okay, so we read it, soluble reactant. So soluble reactant is red pen. Soluble reactant is red pen. And that is AQ. Okay. So next, PbH2, we cross over. We will have Pb2 plus H minus. Pb2 plus H minus. Again, you always have to cross over because I can have multiple charges on Pb, right? So if it's Pb2 plus is different from Pb1 plus, different from 3 plus, the story is totally different. Make sure you cross over to find the charge, okay? So if I were you, actually, you may want to write down the charges, okay, yourself. So for example, I can have NH4 plus and then N3 minus. I think it's better for you to write down the charges, so then especially like Roman numeral, you will not look up the wrong charge. So Fe2 plus O2 minus, so Na plus, this is CO2 minus. So write down all the charges, okay? Because Roman numeral makes a different story. So Pb2 plus H minus, Pb2 plus H minus. So write down all the charges, okay? So H minus is hydride. So we want to look up hydride and to see if Pb2 plus is a exception, okay? So hydride, they follow the same thing as bromide. So hydride H minus are soluble. Do we have exception? Except those of Pb2 plus. Yes, we do have exception. So in other words, if this question is PbH4, if this question is PbH4, then you will have Pb4 plus. Pb4 plus will not be an exception because here is Pb2 plus only. So make sure that you listen out the crossover, or like you have it in your mind. Like don't just look up, oh, Pb is already the same thing. You have to see if there are multiple charges. So we will write the sentence is H minus are soluble except those of Pb2 plus. Okay, so we're gonna use the black pen here. So H minus, okay, this is not H plus, it's hydride, okay? H minus are soluble except those of Pb2 plus. H minus are soluble except those of Pb2 plus. So we underline soluble except, meaning insoluble. Insoluble. So insoluble product should be green pen. Insoluble product. And this should be PPT. Insoluble product will be PPT. And I think you can do the same thing. Now, why do I need to point out this one? The bottom part is like, see the top part is like formula. The bottom is just the name. But when we write, instead of like writing H minus, we will probably write hydride. So we just name. We just use the name, okay? So let's look it up. Mercury 2 iodide. So mercury, tell me that is Hg2 plus, okay? It's a 2 plus, okay? It's a 2 plus. So let's look it up, okay? So how do you read it? Is iodide are soluble. Okay, is an exception. Like iodide is the same as chloride. So except those of mercury 2 plus. This is mercury 2 plus. Hg2 2 plus. Hg2, the 2 is on the bottom and then 2 is on the top. Okay, so there's exception here. So instead of writing I minus, we write the word. Okay, because they give me the word. So iodides are soluble. Iodides are soluble except those of Hg2 and then 2 plus on the top. Iodides are soluble except those of Hg2 2 plus. Okay, so I do. Oh, this should be black pen. Okay, this should be black pen. This should be black pen. So I do have exception here. So I put insoluble. Okay, so this will be insoluble reactant. So insoluble reactant will be blue pen. So insoluble reactant. So blue pen here. Insoluble reactant. So insoluble reactant, we will say solid. Okay, again, this part should be black pen. Okay, this should be black pen. Okay.